Number 91, let f be a polynomial function with values of f prime as selected values of x given in the table above. Which of the following must be true for x is in between -2 and 6 exclusive? So we're given some selected values of x, and we're given the f prime value, aka the slope, right? So at those particularly selected x values, it seems like the slopes are all positive, meaning, well, it looks like it's increasing all throughout. Once again, listen to my words carefully. I said it looks like it's increasing all throughout. Is it really? Well, let's go ahead and take a look at the answer choices and see if that is true. Here we go. So, which of the following must be true? If I can prove even one case where it wouldn't necessarily be true, then I'm going to get rid of it, right? So I already know the answer choice is B here. So instead of explaining why B is correct, let me just prove it to you why the other choices are all wrong, right? So first of all, starting off with choice A. The graph of f is concave up. What does concave up mean? That means your f double prime is positive, aka your slope is increasing, right? Aka in more of a physical sort of senses, well, it is accelerating, right? Not only is your slope positive, but that positive slope is even increasing. Is that what's necessarily happening? Absolutely not. Take a look at your table. The first two f prime values, your slopes, you can already see that, okay, fine, they're both positive, but you went from +3 to a +1. That's called deceleration, not acceleration. So that's not concave up, that's actually concave down. That's why A is already wrong. Once again, I know B is the right answer, so let me go to C first. F is increasing. Now, if you look at it like this, okay, fine, it looks like it's increasing all throughout because your slopes are all positive, but like I said, only at those particularly selected values. For example, let me just kind of give you a very hypothetical scenario, right? So I'm going to go ahead and draw this f prime graph. And once again, it's going to be very, very rough, probably not even accurate, but just to give you an idea. At -2, the value is 3, okay, so like somewhere over there. And then at 0, the value is 1, so like somewhere over there, right? So I don't know how the graph looks like, right? But I'm just going to go ahead and connect these 2 points. But instead of going like this, how about I draw something like this? Boom, 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 boom. Now, is that really going to be the case? I don't know. Maybe, maybe not. But the point is this, I don't know how this f prime graph exactly looks like. I only know the particular values at those selected points, but I don't know what happens in between the intervals, aka from -2 to 0. I don't know exactly what happens. So I don't know if it was increasing all throughout, or maybe it was decreasing for a little bit and then increase again and decrease and increase. I just don't know. And same goes from 0 to 3, 3 to 5, 5 to 6, okay, fine, you can see that, it's still increasing, but the other ones, I don't know. But even then, 5 to 6, like what if like it was decreasing from 5 to like 5.5, right? So I have no idea. So it can be true, it doesn't necessarily have to be true though, which is why the question wants something that must be true, that's why C is out. And the other choices D and E also carry sort of like the similar logic, because if you look at choice D, it says F has no critical points. Once again, if you just look at it like this, yeah, it looks like it doesn't have any critical point. What the hell is a critical point? Where your F prime is 0. But what did I just say? I don't know how the graph looks. If it genuinely looks like the way that I drew it, then it definitely has all these critical points. So maybe, maybe not. I don't know. But the point is, it doesn't necessarily have to be true. That's why D is wrong. And look at E. F has at least 2 relative extrema. Maximums and minimums, aka where your F prime is 0. Once again, I just don't know, right? Which is why it doesn't necessarily have to be true. But take a look at what answer choice B says. It says the graph F has at least 2 points of inflection. What the hell is a point of inflection? That's when your slope changes the direction, right? So take a look at what's happening to your F prime, aka your slope, just from the table alone. It went from 3 to 1, so it went down. 1 to 4, it went up. 4 to 7, it went up. And 7 to 5, it went down again. Take a look. It changed its direction once right here, down to up, and then another one down here, up to down. So it changed its direction at least 2 times. So that's why for sure we can say, yeah, the graph has at least 2 points of inflection just from this table alone. But the other ones, they can be true. They could also not be true. So since the question wants something that must be true, that's why choice B is the only thing that we can say. This one has to be true.